You can see from the previous video I removed all that erroneous color information, and then down here I changed these back to 0 because we are tightly packed and we have 0 stride. It's one position after another position. Now, if I build and run our program again, you'll see that the ship draws just fine, but our boundaries do not draw. I want to draw the boundaries. I want to focus on that in this video. And here's where we actually do the drawing. If I take this method out and build, or this function, sorry, a function method, too many languages. If I take that out, we don't draw anything. All right, but if you look at this function, we say GL draw arrays. Draw some triangles, starting at the first element out there in buffer land, and 3 vertices. Okay, not 3 floats, 3 vertices. So draw the first 3 vertices in the buffer. All right, but which buffer are we talking about, and where in the buffer are we talking about? That doesn't make sense. We're not telling it to do anything else except draw 3 vertices. So how does OpenGL know which vertices to draw? That all comes down to this function, GL vertex attrib pointer. Now in the last video I showed you what all these parameters meant, and when we say GL attrib pointer, notice I'm not telling OpenGL which buffer object to point into. At this point we have a buffer object for the ship. I'll just say ship buffer object. And then we have another buffer object for the boundary. So boundary buffer object. We have 2 of those. Then we have the binding point, GL array buffer. I'll just put array buffer here for the binding point. And when we say vertex attrib pointer, we're giving it a location to read the attribute, the position attribute in this case. We're saying read the attribute in whatever buffer is currently bound to the array buffer binding point. All right, well, the buffer that's currently bound there is the ship vertex buffer ID. Remember, we just barely put that in there to make sure we drew the ship. But what if I turn around and say, you know what? Let's try drawing this boundary one instead. I'm going to come in here. I'm going to disconnect this, and I want to connect the boundary buffer object instead. So let's do just that. Boundary vertex buffer ID. And then I'm going to comment this out because I don't want to overwrite the data that we saw in a couple videos ago. I don't want to overwrite that with our ship data. So I'm going to comment that out for now. And let's say draw. Let's say draw. So here we go. We draw. And there you go. We're drawing the first 3 vertices of our boundary. Remember our boundary, we set up the vertices to 1 right here, and 1 right here, 1 right here. And then we also have one about right here, but we're not drawing that one. We said draw 3 vertices, and so it said, okay, here's 1, 2, 3 vertices. And we also said draw it as a triangle. So there's our triangle, like so. I'll just clear that off and start over again. Draw a triangle, 3 vertices. There we go. I wonder, could I say let's draw 6 vertices? Well, we don't have 6 vertices, and now I have to get in indices, and that's going to be a future video. So just bear with me now. The GL attrib pointer, we're setting up the pointer where OpenGL is going to pull the data that it's going to draw. This is a very critical function for draw arrays because we're saying draw the data at that location, and that location is the location within whatever buffer is currently bound to the array buffer binding point. So let me Control Z through all this and get it back to how it was originally when we started the video. Let's just make sure our ship is still drawing. It is drawing. Very good. All right, I want to draw the boundaries. Okay, so what I'm going to do is I think I'm going to actually take this buffer subdata column, put it right here. Let's bind to the ship buffer. Let's send down the transformed verts. Enable this attrib 0, which is the position attribute. In fact, we actually don't. We only need to enable it once. We don't need to keep re-enabling it. So I'm actually going to do that right when we initialize GL. Do it once and be done. And then we can get rid of that comment. Draw. All right, set up the pointer to point into the ship vertex buffer. Draw the ship. Let's Control F5 this and just make sure the ship's still drawing. Yep, very good. All right, I want to draw the boundaries. All right. Well, first thing we need to do is bind to the proper buffer. So GL bind buffer, the array buffer binding point, I want to be the boundary buffer ID. So we'll make that connection. And now we have to set up our pointer again. All right, if we don't set up our pointer again, and I say, hey, draw 3 vertices. Let me just comment this out. If I say draw 3 vertices, well, it's still going to be pointing to the buffer that it was set up when we originally call vertex attrib pointer. Let me just draw that out again. Ooh, that's big. I don't want that. I definitely don't want it that big. Awkward. Anyway, we bind the ship buffer object, and we'll do the boundary buffer object, the exact same ones I've done before. We bind to the ship vertex buffer ID. That is our array buffer binding point. Array buffer binding point. And then we say set up the attribute pointer to be within the data, the actual data in the buffer for that. So we're gonna say our attrib pointer is there. Here in black we'll do our attrib pointer. We set that up to like so. And then I say, hey, bind buffer, break this blue link. Alright, let's do medium. Break this blue link and bind it to over here instead. Okay, but the attrib pointer is still pointing into the ship buffer object. So even though I've rebound to a different buffer, the attrib pointer call, we called that while we were still bound to this object. So we're pointing to these attributes. So if I run this, you'll still see the ship draw, not the boundaries or that crazy sideways triangle we've seen in previous runs. We still get the ship, and we're just fine. All right, so there you go. I've proved that GL draw arrays uses whatever is last done by a attrib pointer, which was set up with whatever was currently set at the array buffer. Hopefully you're seeing the state machineness of OpenGL come forward. It's important that things are set up correctly and bound correctly before we say actually go and draw. I want to draw the boundaries. All right, so let's bind to the boundary vertex buffer ID, and then we're going to have to do an attrib pointer call again, because we don't want the attrib pointer pointing to the data in the ship buffer. I want to instead, here are our boundary vertices, 4 of them. I want this attrib pointer, this black pointer, to be pointing into the data for the boundary buffer object. Well, we're currently bound to the boundary buffer object, so all we need to do is an attrib call to set up that state. So GL vertex attrib pointer 0 attribute 0, the position attribute. It's 3 floats again. GL float, not gloat, float, and GL false. Again, this is normalized stuff, don't stress it. And we're packed tightly. We have no stride. There we go. And now I can say GL draw arrays 0, 3. Let's run this, see what happens. And there you go. We're drawing these 3 vertices. Remember we said draw 3 vertices as a triangle. It's filling in the triangle for us. Not ideal. What we really want to happen is we want our diamond. Don't we have this little lone vertex out here on the right being abandoned? We want to draw that vertex. And we also don't want to fill it in like this. Okay, we want to leave our playing field open. We just want to connect the dots with lines, so to say. So you might think, well, we have, let's see, Jamie, I believe we had 4 vertices, did we not? Well, then couldn't you just change this to a 4? Well, no, because we're drawing triangles, and the 4 it's just going to ignore. It's looking for groups of 3, so it's 3, or it's 6, or it's 9, or it's 12. 4, it just says, well, I just won't do 4. I'll do 3 for you instead. I don't want triangles. I want lines. Let's try lines. GL lines. Well, if we run that, let's see what happens. We get nothing. Okay. Lines means draw a line, don't fill in the triangle. But then lines, what lines does is it connects the vertices with the line, 2 vertices at once. So let's go back up to our data. When I say lines, it's going to connect this one with this one, and it's going to connect this one with this one. And so we're not going to get a diamond. We'll just get 1 line here and 1 line here. Let's go back down. GL lines, start at 0, 4 vertices. I'm actually confused why we're not getting lines. We should be getting lines. Let me pause the video, see if I can figure out what's going on. Okay, it actually wasn't that hard. We had line, and we want lines. I'm not sure why they have a GL line enum. I'd have to go look that up in the documentation. When I say GL lines, what OpenGL does is it takes the first two vertices and connects them with the line, and then it takes the next two vertices and connects them with the line. And so you can see we've left these. We didn't connect these two vertices with the line because they got consumed. Let me just illustrate that with the actual data. I'll go up here to the boundary verts, and this line right here is the connection of these two verts, and then this line right here off the screen is the connection of those two verts. So if I want to draw this line and this line, I have two options. I can duplicate my verts, or I can use some element indices I'll show you in future videos. But for now, I think just to prove to you, to get our lines up and going, let me duplicate the verts. So I want to go from here to here, and then I want to go from here to here, right there, and then I want to go from there to there, and then I want to go from here back to the original one. Okay, I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. And then down here, I need to say, hey, there's 8 vertices, connect them. And there you go. There is our playing field finally. Now, obviously, we're not interacting with it yet. And we will eventually using dot products. But in the next videos, I actually don't like this data duplication. You could see if we wanted to do a lot of lines and things, we'd have to duplicate a lot of data. So in the next video, I'm going to show you how to get around this by using indices instead of just vertices like this.